Hello friends, welcome back to our channel. Today we are diving into a very important topic for any C# developer, which is asynchronous patterns. Whether you are building a desktop application, web application or services, understanding these patterns is crucial for writing efficient and responsive code. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Mastering asynchronous patterns in C#. Okay, so first let's understand what asynchronous patterns are. Asynchronous patterns in C# are ways of writing code that allows a program to perform tasks in the background without blocking or freezing the main thread. What does it mean is the program can keep running and responding to user actions like clicks or keyboard inputs while waiting for other tasks like downloading a file or reading the data until it completes. Okay, so let's understand it with the help of scenario over here. Let's imagine you are using a music application on your computer. You want to download a new song from the internet via the application while simultaneously browsing through your music library to select which songs to add to your playlist. In a synchronous approach, what happens? You click the download song button, the program starts downloading the file. While the song is downloading, the entire application freezes. If you want to browse your music library, you can't do as the entire application is freezed. Once the download is complete, the application unfreezes and you can continue working. But in an asynchronous approach, you click the download song button, the program starts downloading the file in the background. While the file is downloading, the application continues to work smoothly. You can browse your music library, select other songs to add to your playlist, view the progress of the download in a small status bar or any notification area. So if you decide to click on another song while waiting, the app responds immediately. You can continue to enjoy the app without interruption. When the download is complete, you get a notification or an update in application saying download completes. Your song is ready to play. So this approach allows you to use the application seamlessly without feeling like you are waiting for a task to finish. You can interact with the application, make decisions, and manage your music while the download happens in the background. So what we observed from this approach, you will get better experience. You appreciate being able to multitask without interruption, right? Second, what you will get efficiency. The program uses system resources effectively by not blocking the main thread, allowing it to handle other user inputs and tasks, right? Number 3, feedback. You receive feedback on the download process, keeping you informed without taking away control from you. So now we understood what problem asynchronous pattern solves, right? You must be thinking, okay, I understood what asynchronous pattern is and what problem it solves, but how to implement it in the C#, right? It's very simple. Let's first understand how many primary asynchronous patterns in C# are. So basically, there are 3 primary asynchronous patterns in C#, which I have shown over here: APM, EAP, and TAP. APM stands for Asynchronous Programming Model, EAP stands for Event-Based Asynchronous Pattern, whereas TAP stands for Task-Based Asynchronous Pattern. APM, Asynchronous Programming Model, is one of the older asynchronous programming pattern in .NET. It uses pairs of begin and end methods for asynchronous operation. If you see, it was introduced in .NET 1.0, C# 1.0, right? So APM was the first asynchronous model in the .NET, primarily used the early version of the framework. That's what I have mentioned, .NET 1.0 over here. It relies on 2 methods, beginAx and index methods, to start and complete asynchronous tasks. When we talk about its return type, it returns async result, and the end method is used to retrieve the result or ensure completion of the task. When we talk about its uses, it uses beginAx and index methods. It could be begin read, begin write, end read, end write method, something like this, right? So we start an asynchronous operation with beginAx and must call index once the task finishes to retrieve the result or handle errors. When we talk about this pros, it's efficient for low-level asynchronous operation, and it was a crucial pattern in early .NET application. Its cons, it's difficult to manage because of manual callback handling and complex error handling, making it less readable and harder to maintain. That's what I have mentioned. Cons over here: difficult to use and harder error handling. Now let's talk about the EAP, event-based asynchronous pattern. The EAP introduces a more user-friendly approach by allowing developers to use events for signaling task completion and progress updates, often used in the UI application. And it was introduced in .NET 2.0, C# 2.0. Return type. EAP methods triggers events like completed or progress change, and developers subscribe to these events to handle task completion or updates. That's what I have written, events and callbacks over here as a return type. Its uses. So asynchronous operations are started using method async. For example, download file async, and progress or completion is tracked by event handler like download file completed. So that's what. It uses method async and it is going to use the event handlers. So that's what. I have mentioned method async and events over here. Its pros. It's ideal for UI application with built-in support for progress reporting and the background operation. That's what I have written, good for UI apps and simple progress reporting. Cons. The code can become verbose and lacks the flexibility and simplicity of the modern task programming with no built-in support for the task. That's what. It's verbose and no native task support. This is the cons of the EAP. Okay, so finally we have the TAP, that is task-based asynchronous pattern. The TAP is modern and preferred asynchronous pattern introduced with the task class and leverages async await for simpler and more readable async code. And it was introduced in .NET 4.0, C# 4.0, right? When we talk about its return type, it returns task and task T, which can be awaited, making code flow easier to manage and more synchronous like. Uses. Async await. So we use async to mark methods as asynchronous and await to pause execution until the task completes. So basically, it enables cleaner, more readable code. Pros. It's modern and preferred, cleaner syntax, built-in support for cancellation. So these features making it modern standard for the async programming. When we talk about the cons of this tab, it's slightly more overrated due to task creation, but this is generally minimal and outweighed by the benefits of readability and maintainability. Okay, so let's switch to the Visual Studio and see all these things in action. Okay, so here we are on Visual Studio. Here we are going to see the demo of the Asynchronous Programming Model, which is nothing but the APM in C#. So this is an older asynchronous pattern in .NET. So here what we are going to do, we are going to use begin and end method for asynchronous operation. Specifically, if we talk about what we will be doing, our code will be reading the content of a file asynchronously using the file stream class and the APM pattern. We will see, first of all, to show the demo what I have done, I have created one console application named Asynchronous Pattern Demo that has program.cs file. In program.cs file, first of all, I have added necessary namespaces like using system, using system.io, using system.txt. So using .system, it provides the basic functionality like console.writeLine, something like this. System.io, it contains the classes that basically help us to work with files and streams, such as file stream for reading and writing files. Whereas system.text namespace, it includes classes for working with text and encoding, such as encoding.utf8 to handle character encoding, something like this. Okay. Then there is a class named APM example. It has helper class, a state object. So this class is created to store the state of the asynchronous operation. So it contains two properties, file stream and buffer. File stream refers to the file being read, whereas the buffer, it basically a byte array used to store the data being read from the file. Then there is a main method, which is an entry point of this application. So here, first of all, I'm just printing this statement into console window. APM, which is nothing but Asynchronous Programming Model demo. Because I'm just giving the demo of the APM over here. So that's what I just wanted to print this statement into console window. Here I have written file stream fs is equal to new file stream file.text file mode.open. So this file stream object I'm creating over here to open the file.text for reading, and the file mode.open, basically it specifies the file should be opened if it exists. Then I have written byte array buffer. So basically I'm just creating a byte array buffer where its size is set to the length of the file. That's what I have written, new byte fs.length. So basically what I'm doing over here, I'm just allocating buffer based on the file size. Okay. Then I'm just creating a state object to store file stream and buffer. That's what I have written, a state object state, new state object. Here I'm assigning file stream is equal to fs and buffer is equal to buffer. So With this statement, our state object is created where it is storing file stream and the buffer. Why I have created this object? Because this object will be passed to the callback method once the asynchronous read operation completes. Okay, then I have written fs.beginRead. So basically what I am doing over here with this statement, I am just going to initiate the asynchronous read operation. So it takes a couple of the arguments like buffer. So buffer, the buffer that will hold the data being read. Here I have passed the 0 as the second argument. So this is nothing but the offset in the buffer at which to begin writing the read data. And then I have mentioned buffer.length. So maximum number of bytes to read equal to the file size over here. Then I have written read callback. So this is nothing but the callback method that will be executed when the read operation is come. And finally, I have passed this state object. So this state object that basically contains the file stream and the buffer, and which will be passed to the callback. That's what I have mentioned state as a final argument over here. Then what I'm doing, I'm just printing this statement into console window, reading file asynchronously. And then I have written console.readLine. So this statement basically helps us to keep the console open until the asynchronous operation completes. Now let's review the callback method, which is called when the read operation completes. So here I have written private static void read callback async AR. So here I'm just going to retrieving the state object that contains the file stream and buffer. That's what I have written ar.async state. I'm just casting with the state object so that we will be getting an instance of this state object that I'm holding into this variable state, right? Then I have written file stream fs is equal to state.filestream. So basically with the help of these properties, I am getting the file stream that I am storing into the fs variable over here. Then I am getting the buffer byte array with the help of this properties of this state object. That's what I have written state.buffer. So basically I am getting the buffer that I am storing into the byte array buffer variable. And then I'm just issuing this statement fs.endReadAR. So here this endRead method, what it does, it completes the asynchronous read. So this method returns the number of bytes that were read, which is stored in the bytes read. That's what I have written, int bytes read is equal to fs.endReadAR. And then finally I'm just printing byte reads and how many bytes has been read, that I'm printing into this console window. And then finally I'm just issuing fs.close. So basically it closes the file string. And then I'm just converting bytes into the string. The data read from the file is stored in the buffer. So to convert into the human readable string, we need to use encoding.utf8.getString method. So what it does, it just converts the byte array into UTF-8 encoded string. That's what I'm just storing this output into the file content of a string data type, and finally I'm just printing this file content into the console window with the help of this statement, console.writeLine file content file content. Okay, so that's how this program is structured. Let me go and execute this program and show this output to you. Okay, so output got appeared into this console window. If you see, this APM Asynchronous Programming Model demo got printed, then reading file asynchronous got printed, right? So reading file asynchronously got printed, line number 29, right? From this statement, this line got printed, right? Reading file asynchronous. Then it is just printing bytes read 766. So here, bytes read 766, it got printed from line number 44. Right, bytes read, that is the number that I'm printing into the console window. Bytes read is equal to 766. And then finally file content got printed. So the file that I'm opened, file.txt, this file contains this much text. Like asynchronous pattern in C# are ways of writing code that allows a program to perform tasks in the background without blocking or freezing the main thread. There are three primary asynchronous patterns in C#: APM, EAP, TAP, and APM asynchronous pattern introduce return type, uses pros and cons. So those got printed as a part of file content into this console window. You have seen this APM model, it uses begin and end method of the asynchronous operation. In this case, what we have used begin read to start the operation and end read to complete it. That's how we implement asynchronous programming model in C#. Okay, so now let's see the example of the EAP, event-based asynchronous pattern demo. So again, we have one console application named Asynchronous Pattern Demo that has program.cs. In program.cs file, first of all, I have added necessary namespaces like using system.net. So here, using system.net, it contains the classes used for network communication such as web client that allows downloading files and other data over the internet. That's what I have included this namespace at the top. Then there is a class named EAP example that has main method, which is the entry point of this application. So first of all, I'm just printing this statement into console window. EAP event-based asynchronous pattern demo. Okay, next what I'm doing, I'm just creating a instance of this web client. That's what I have written. Web client is equal to new web client. And this web client class is available into the system.net namespace, right? Then what I'm doing, I'm just going to subscribe to the download file completed event. So for that, what I have done, I have written this statement. Client.download file completed plus equal new system.component model dot async completed event handler, and here I have passed this on download file completed. So here EAP uses to signal when an asynchronous operation is complete. In this case, the download file completed event is fired once the file has been finished downloading. And what I have done over here I have done the subscription to the event by attaching the on download file completed method to the event using this plus equal to operator. So this means that when the download is done, the on download file completed method will be called. And then I'm just starting asynchronous file download. So here I have given the URI, right? So this is URI nothing but the one of the PNG file that I'm planning to download via this asynchronously method. Next, what I'm doing, I'm just going to start the asynchronous file download. And here I have mentioned the URI over here. So here what I'm doing, I'm just going to use this instance of this web client.download file async. Here I have written file URI and this is the name of the image. This method initiates an asynchronous download of the file specified by the URI I have mentioned as a first argument of this method. And the second argument is nothing but the local path where the download file will be saved. So basically I have written this file name that will be stored at the root folder of this application. And then finally I'm just printing this statement, downloading file asynchronously. And here I have written the event handler for download completion. So this is the method I have subscribed under this subscription, right? That's what I have written on download file completed. This method as an event handler will be called automatically once the file download is finished. If we get error, then I'm just printing this statement, error downloading file, and what is the error message we got it, I'm just going to concatenate and print into this console. If there is no error, then I'm just printing download completed success. So that's how this program is structured. So let me go and execute this program and show this output to you. Okay, so output got appear into this console window. If you see, EAP event-based asynchronous pattern demo got printed, downloading file asynchronously, download completed success. So overall, these programs help us to download a file from the internet. Instead of waiting for the file to download, which could take some time, making our entire program freeze. The program says, I will start the download, but I don't want for it to finish. When the download is done, I will call you back to let you know. So that's what this pattern does. It starts a task like downloading a file, and once the task finishes, it fires an event to get the program know that it's done, right? And that's how this statement got printed, download completed successfully. And this statement got printed from this event handler. When this download gets completed, this event got invoked and there is no error. So this statement got printed, downloaded completed. Now let's see the final demo, which is related to TAP, task-based asynchronous pattern. So here again, I have created one console application named Asynchronous Pattern Demo that has program.cs file. In program.cs file, first of all, I have added necessary namespaces like using system.net.http, using system threading.task. So here, system basically provide the basic C# functionality like console.writeline or something like this. System.net.http. It contains classes for sending HTTP requests and receiving responses such as HTTP client. And then finally, we have the system.threading.task. So basically, this namespace supports asynchronous programming specifically for using tasks. So here we have one class named tap example that has main method, which is an entry point to this application. So here, if you see, we have marked this method with the async keyword. Why I have marked with this async keyword? Because I want to indicate that the method can execute asynchronous operation using the await keyword. That's what I have marked this method with the async keyword. And then what I'm doing, I'm just printing this statement into console window. Tap task-based asynchronous pattern demo. Then I'm just writing one URL. So this is the URL of our YouTube channel, right? https www.youtube.com/learn-enjoy triple dot, right? So this is one of the URL I have mentioned that I have stored into the a string variable named URL, right? Then finally what I'm doing, I'm just starting the asynchronous HTTP request. For that, what I have done, I have created an instance of the HTTP client inside this using block. Why I have used the using block? Because using block ensures that the HTTP client's instance is disposed properly after it has been completed. That's what I have written inside this using block, this instance creation. Okay, then what I'm doing, I'm just writing this statement: a string result is equal to await client dot get a string async, and I'm passing the URL against this method. This line is the very important line because this is the core part of the asynchronous code in this program. Here I have mentioned the await keyword. So this await keyword is used to pause the method until the task completes without blocking the thread. The rest of the code can continue executing while waiting for the HTTP request to finish. And then what I'm doing, I'm just printing this statement downloaded content. And here, whatever the downloaded content I have stored into the result variable, I'm just printing into the console window. So that's how this program is doing. Let me go and execute this program and show this output to you. Okay, so output got appeared into this console window. If you see, cap task-based asynchronous pattern demo got printed and downloaded content, all the HTML contents, right? That is used in this YouTube URL that I have mentioned as a string URL, right? It downloaded the content and printed into this console window with the help of task-based asynchronous pattern. Okay, so that brings me to end of my session today. To sum up, in today's video, we learned what asynchronous patterns are, and we discussed in detail about three primary asynchronous patterns: APM, EAP, and TAP. Mastering these asynchronous patterns in C# will definitely make you a more effective developer. Understanding when to use APM, EAP, or TAP can help you create applications that are responsive and efficient. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.